Hello geometers, this is Miss Backfish, and I want to go over a worksheet that I have assigned my students to review arc length and sector area. Now this is not my worksheet, this is Mrs. Greiser's worksheet, but I like this worksheet and want to show them how to complete some of the problems. This worksheet has two sides. The one side is on arc length, which is always related to circumference. The other side is on sector area, which is related to area of the circle. So we worked the examples together in class, and their assignment was to do the problems right here. So if you're just watching this video at home and want to try these problems before I go over them, pause and go ahead and do that. All right, so this is under the U try. For A, it says find the circumference, and it's given me the diameter. Circumference formula is 2 pi r. Sometimes we also think of that as pi d. For the purpose of this video, since we're dealing with both circumference and area, I'm just going to stick with r and say, well, then if this is the diameter, half of that is the radius, and that would be r. So we have 2 times pi times 8, and that gives me 16 pi. Notice it says give exact and estimated answers. Exact form means you have it simplified with pi and you still see the pi symbol. There's still a pi in there. By the way, this is inches. We're just using units of length because circumference is just like length around a circle. Now, if I want to give an estimate, that's when I get a decimal. Decimal answers are estimates, if you have to round technically. But so this is an estimated answer or an approximate answer. And so I have to round it. If you are not told what to round to, which you're not here, a good middle ground is to the hundredths place, 2 decimal places. So I look at the 6, and because the 5 is 5 or higher, I round up. So it's 50.27. So this is approximately 50.27. Okay, a lot of times people have trouble with the idea that exact means this. We're used to, I think, in science, thinking about precision and a number of decimal places. But this is a rounded answer. So it's not as exact as this answer. So taking out your calculator to get a rounded answer is actually making your answer a little bit less accurate. So exact answers are great. So that's what you should have gotten for A. Part B asks to find the radius, and they gave me the circumference. So remember, if we're using circumference, then we're using circumference formula. They gave me what this is equal to, so I'm going to set it equal to that. So I'm just really using this part here now. I have an equation that I want to solve. To get r alone, I'm going to divide both sides by 2 pi. All right. Now, some people would say that that's an exact answer. Technically, we're not supposed to leave irrational answers in the denominator. So if you were asked for an exact answer on this, theoretically, you could say 35 over 2 pi. Really, it's better to get a decimal answer for this one. So let's go ahead and do that. 35 divided by 2 pi. Please notice what I'm doing here. If I do this by division, please make sure you put the 2 pi in parentheses together, because this is saying I want to divide 35 by the whole quantity 2 pi. Can't see my hands. The whole quantity 2 pi. It's a thing. If I do this, my calculator does something different. It says 35 divided by 2. Let me get that answer and then multiply the answer times pi. So the calculator needs to understand that you want it to divide by 2 pi altogether as a clump. You can also do that by doing the fraction button. Because if it sees that your calculator says, oh, look, 2 pi is all together in the denominator, we're dividing by all of that as a whole. So my answer here would be 5.57 approximately. And those are yards according to the units I was given. Part B is asking me to find an arc length. So now they gave me the central angle, 40 degrees. That means the arc measure is in degrees, would also be 40 degrees. We need the length of that arc. This is where I like to do it as a proportion, which is one reason I like Miss Greiser. She does too. But notice she's got it set up both ways here. Here it is as a proportion, or you could also think of it like this. They're the same thing, just written two different ways. Okay, I like to use a proportion because I can be consistent and always use a proportion. Meaning, arc length and sector area and degrees, they're all parts of a circle. They're all the same size piece of a circle. So in other words, however much of the circle 40 degrees is out of 360, whatever fraction of the circle that is, which is technically 1/9, that's the same amount of the circle my length of AB is going to be. And since it's length, I'm saying, well, then the whole circle is the circumference. 2 times pi times r. So arc length is a piece of the circumference, just like however many degrees you have is a piece of 360 degrees. So that's proportional. So I'm going to cross multiply. I'm going to go ahead and call this x. Sometimes we call it s, but I'm not going to. So 40 times 2 times pi times 6. 2 times 6 is 12. So 40 times 12 pi equals 360 times x. I like to get everything alone, get my variable I'm solving for alone on one side before I go to the calculator. So that would be here. I'm ready to input it in my calculator. 40 times 12 pi, all divided by 360. This is my decimal approximation. If you are using this type of calculator, it will get it back in exact form for you if you press this button right here above the enter. It's not the only way you could do it, but it's the handiest. So that gives me 4 pi over 3, 4/3 of pi. You could also get that, if you're not using this type of calculator, by basically simplifying this. 40 times 12 is 480, and then you're simplifying 480 over 360, and you get 4/3. All right, so here's my answer for the length of arc AB in letter C. Letter D, find the circumference. So this time, the 81.64 that they're giving me, that is the length of an arc. And from where it's written, I'm going to assume they mean that that is the length of the arc from A to B that passes through C, or arc ACB, or BCA. Okay. They also tell me that this angle is 260, so the measure of that arc would be 260 degrees. So I've got 260 degrees out of 360. That's how much of the circle I have in degrees. And in terms of length, I have 81.64 out of the whole circumference. Now, a lot of times we do this. We break it down into the circumference formula on the denominator. That's really particularly helpful if I want to find r. But this time, I really want to find the whole circumference. That's what I'm being asked for. So I could just call this whole thing C and solve for C, which is what I think I'll do. Because that's what 2 pi is, 2 pi r is. So now I've got cross multiplying, 260 times C equals 360 times 81.64 is 29,390.4. Okay. And now to get my circumference alone, I divide both sides by 260. And that gives me 113.04. So the circumference of this circle is about 113.04. Really, it's not approximate. It looks like that's it. We're done. So I could just have used an equal symbol here because I didn't have to round. All right, E, find the radius. Looks very much like D. They gave me an arc length. That's what this is. I know because of the units. That's a unit of length measure, and also because there is not a degree symbol. And because it's not 45, and they already told me this central angle is 45 degrees. So it's very much like what we had over here. The difference is here we wanted the whole circumference, here we need the radius. So I do need to break down the circumference formula in my denominator. So in other words, I'm going to say 45 degrees out of 360 gives me this much length out of the total length. Total length, when I say that, I'm talking about the length all the way around the circle, the distance all the way around the circle, the circumference. All right, so I'm going to leave it as 2 pi r so I can solve for r. So when I cross multiply, I get 45 times 2 pi r. And when I cross multiply the other way, 1.57 times 360 gives me 565.2. Now I need to get r alone, so I'm going to divide by all of this. Let's go ahead and simplify this a little bit. This is not a decimal. It's 45 times 2 times pi. 45 times 2 is 90, so this is 90 pi. So I'm dividing both sides by 90 pi. Again, if you write this as division in your calculator, make sure you put the 90 pi in parentheses. It might be safer just to use the fraction button, if you have one. If you have to do it as division, make sure you put 90 pi together in parentheses. So this gives me about 1.998. So r is about 2. That's the answer to letter E. Finally, F. A skateboard wheel has a diameter of 56 millimeters. How many revolutions does the wheel make when traveling 3 meters? Oh, that's a good one. So let's see. We've got our circle. And they're telling me that the whole distance here is 56 millimeters. Okay. Now, how many revolutions does the wheel make? What does the wheel make when traveling 3 meters? When you have a wheel traveling, and I'm not sure how I'm going to show this well, but if I have a wheel and it is turning and going this way, for instance, then what you can think of is that it's like you're taking the circumference as it turns, and this is being laid out along the ground. In other words, as it rolls, this point is here, and then this point is here, and then this point is here. So the distance it goes has to do with the circumference. So I want to know what the circumference of this is. So let's do circumference for this. I could use pi times d because I have the diameter, or I could take half of 56, and that's 28, and say 2 times pi times 28 is 56d. 56 pi, excuse me. All right, so 56 pi, what that's telling me in this context is if I rolled this circle along the ground and just rolled it around one time so that it comes back to being on the same point over here, then this distance here is the circumference. That's the distance around the circle. So if they want to know how many revolutions, how many complete turns, that's like asking how many times does it do the whole circumference? Because one whole turn is like laying the whole circumference along the ground. You could think of it as having a big hoop, and it's been painted and it's wet. And as you roll it, it's laying out wet paint along the ground. And when it comes back to where it started, the line of wet paint on the ground is equal to the distance all the way around the circle, the circumference. Okay, so if we want to know how many revolutions this wheel makes when traveling 56 meters, let's go ahead and convert to decimals here so we can think of this a little bit more numerically. 56 pi is 175.9. We're just going to go with 0.9. Now, what we were taking this 56 from was millimeters. So that's 175.9 millimeters. So now 3 meters, we have to figure out what that is. Each 1 meter is 1,000 millimeters. 1 meter is 1,000 millimeters. So 3 of these would be 3,000 millimeters. So we want to know how many times this number, the circumference of the circle, goes into 3,000. So 3,000 divided by 175.9 gets me 17.05. And I think we're going to round that and say we would have 17 circumferences, which means 17 revolutions. So 17 revolutions. Okay, that one made us think a little bit. On the other side, again, there were examples that we did together in class. That's A through D at the top there. And then we have some you try. Again, this side is sector area, and we can set that up either as a proportion, or we can multiply one side out of that proportion and write it like that. There are different ways to write it. There's more than just those two ways to write it. The big picture, though, is realizing that the area of just a piece of a circle is the same size part of the whole circle as any degrees are out of 360, or any arc length is out of circumference. So we're going to do the ones under you try. If you need to do this for your own practice and don't have this worksheet, go ahead and pause here. Try all the ones you want to try, and then catch back up with us.